This is the second part on our lesson on solving square root inequalities. If you want to go back and look at the first part, it shows you how to solve fairly simple square root inequalities that turn into linear inequalities. In this lesson, we're going to look at more complex square root inequalities. So make sure that you have a good background in solving square root inequalities, the linear functions, and also solving square root equations before you start this one. We're going to look at a problem like this in this lesson. Be sure that you remember the steps that we're going to go through, which are we're going to find out what the domain is, because we want to be sure that we don't have x's in our solution that would cause there to be a negative number under the square root sign. So we're going to find that, and then we're going to treat it somewhat like a square root equation, and we're going to isolate a square root on one side, square both sides, and then solve the resulting inequality, and then we'll see what our solutions are and how they match up with our domain. So I'm looking at this problem and I notice there are two different square roots here, so I need to look at my domain that way. I need to first look at the first square root and say x has to be greater than or equal to 0. Nothing to solve there, but that's the first part of my domain, because I don't want any number under that first square root sign that's negative. And then I'm going to use the word and. These have to go together. Not only does that have to be true, but x minus 5, the part under the second square root, also has to be equal to 0. I'm going to solve that little inequality by moving the negative over and making it positive. So both of these parts have to be true. X has to be greater than 0 and x has to be greater than 5. Well, of course, there are some numbers greater than 0 that aren't greater than 5, like 1 or 2 or 3. So we really can't use those because both pieces have to be true. But there are no numbers greater than or equal to 0 or greater than or equal to 5 that aren't greater than or equal to 0. So we're just going to use x greater than or equal to 5 as our domain whenever we get to that piece in a minute. So as long as our x's that we get in our solution are greater than or equal to 5, they'll all be acceptable. If they're not, we'll have to limit them to that. Now I'm going back over to the left side. I'm going to isolate one of the square roots. I'm going to isolate the x minus 5 on the left side. And I'm going to take the square root of x and I'm going to move it to the right side and make it negative, because I moved across the equal. So I subtracted it. Still have a plus 5 over there. Now I have isolated the left side, which is all I have to do. I'm going to square both sides. Notice I said both sides, so I'm putting the square in on the outside of a set of parentheses on the right. The square root goes away on the left. The right side's a little more complex. We have to multiply together two binomials. Again, if you need practice on that, there is a lesson on multiplying polynomials that would be helpful to you. But we're going to take negative x, negative square root of x times negative square root of x, which is negative times negative is positive, and square root times square root just gets rid of the square root. That just leaves x. Then we're going to take negative x, square root of x, times 5, which is negative 5 on the square root of x, and do it again, 5 times negative square root of x, and that gives us negative 10 on the square root of x, multiplying those together, and then 5 times 5, which is 25. So I just took a few shortcuts there to multiply together that binomial. Again, you can look at a lesson on that if you need to. Now I noticed that the resulting inequality is still a square root inequality. It still has a square root in it. So I need to continue by doing it all again. I need to isolate the square root of x that's left. I'll start by taking this x on the right, moving it to the left becomes minus x, which is nice, because now this plus x and that minus x is what it will be. Will just go away. And then I'm going to take the plus 25, make it minus 25 on the left. Minus 25 and minus 5 is minus 30. I'm getting close to having this isolated again. 10 on the square root of x. And all I need to do now is divide by negative 10 on both sides to get rid of the negative 10 in front. If you remember your rules for linear inequalities, they say that anytime you divide or multiply by a negative, you need to flip this inequality sign over. So I did that. And now I have isolated the square root of x, and I can square both sides. So I end up with 9 here. I end up with x here. We actually would prefer to see it written this way, I think. So my solution, at least this part of it, is x is less than or equal to 9. Now I need to compare that to my domain. My domain says that if I get any solutions that aren't greater than or equal to 5, then I shouldn't use them. Well, there certainly are numbers less than or equal to 9, 0, 1, 2, 3, negative 10, negative 50, negative 1 million. All of those are numbers less than or equal to 9, but they're certainly not greater than or equal to 5. So I only want the numbers that go down to 5, so I really am only interested in the numbers between 5 and 9, and I write it like this. The equal signs underneath the less than mean that we include the 5 and 9. Or if you like to write this in interval notation, you can put a bracket to show you include the 5, and also a bracket on the right side to show you include the 9, and that's written in interval notation. So x is going to be between 5, which our domain says it must be bigger than or equal to, and 9, which is what our solution shows, including the 9. Let's take a look at this one. Finding the domain here is not very hard. I go over here to the right. I say x minus 1 has to be greater than or equal to 0, which means that x has to be greater than or equal to 1. So as long as my solutions are greater than or equal to 1, I can use them. So this is my domain, which I like to mark with a D here. Now I'm going back to the left side. I'm going to isolate the square root, so square root of x minus 1, by moving the 3 over and making it minus 3, and I'm going to square both sides. Notice again I'm squaring the whole side. So on the left I have x minus 1, the square root went away. On the right I'm multiplying x minus 3 times x minus 3, binomial multiplication, which is x squared minus 6x plus 9. And then I'm going to look at the resulting inequality. This time I have a quadratic. Now I like to deal with quadratics a little bit differently. I like to treat them as if they are an equation. Set them equal to 0, either factor or use the quadratic formula to find the solutions I would get if they were equations. Check to see if those solutions would be extraneous if I put them into the square root inequality, which I'm going to treat also as an equation. And then the ones that are left after all of that, I'm going to use those as boundary points to decide where my greater than or less than signs are going to go. Sounds hard, but I think we can make that pretty easy. So here's what I'm going to do. I'm going to set this equal to 0, and I'm going to move the x and the negative 1 to the right where the x squared is and put them or combine them with what's already there. So negative 6 minus x is negative 7x, and negative 1 becomes plus 1, so 9 plus 1 is 10. And I look at that and I see that it factors. Notice I changed my sign to an equation, not because I'm solving an equation, I'm just using that to get these boundary points. And I'm going to factor this because it will. If it didn't factor, I would go to the quadratic formula and plug them in and find my two answers that way. This factors into 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. They're both negative because of the sign in front of the 7. And then if you remember, these each factor has to be equal to 0. So in order to cause the first factor to be 0, x would have to be 5. The second factor, it would have to be 2. Now, I'm dealing with this as if it is a square root equation. So I'm playing like this sign up here, instead of being a greater than sign is an equal sign. I'm going to plug these in to make sure that neither of them are extraneous solutions that we need to mark out. So I'm going to go 5 minus 1 is 4. Take the square root of 4, which is 2. 2 plus 3 is 5 on the left side. And 5 is equal to 5. Therefore, this is a good solution. And then I'm going to do the same thing with 2. 2 minus 1 is 1. Square root of 1 is 1 plus 3 is 4. Uh-oh, 4 is not equal to 2. Therefore, this is an extraneous solution that I don't even want to use as a potential boundary point either. Now, here's what I'm going to do with those. I like to look at a number line here. And I'm just going to put that 5 somewhere on this number line, like this. And because my inequality sign is a greater than and not equal, I'm going to put an open circle there to remind myself that I don't include the 5. Now, my domain says x has to be bigger than 1, which is down here, or equal to 1, so I'm going to also mark that point on here. And here's what I need to know. Am I going to shade in the part to the right of 5, which would be from 5 to infinity, or am I going to shade in the part from 1 up to 5? I know I'm not going to shade below 1 because that would be below my domain, and that's going to tell me where my answers are going to be. So here's how I do that. I like to just use a test point. In my case, since I know that 10 out here gives me a nice number in my inequality, I'm going to use 10. I'm going to say if I do 10 minus 1, which is 9, take the square root of 9, which is 3 plus 3 greater than, and I fill in 10 for x, 10. Well, it's not. That means my solutions are not to the right of 10 because 10 is not included as a solution. Therefore, they're probably to the left. I can test that. How about 4? 4 minus 1, going back to the one up there in yellow. 4 minus 1 is 3. Square root of 3 is 1 point something. 1 point something plus 3 is certainly going to be bigger than 4. Is 4 greater than 4? Or something bigger than 4 greater than 4? Well, yes, it is. Therefore, it's included. So this area right in here, the area between 1 and 5, but not including 5, that's my solution set. So the solution to this inequality is x has to be between 1, includes 1, that's the domain, and 5 does not include 5, so don't put the equal there, and it looks like that. So it's all of this part that I shaded in along this number line. Again, if we want to write that in notation here, we'll put in a 1, comma, and this time we don't use 5, or we don't use a bracket with a 5, we use a parenthesis to show it doesn't include 5, and we have it in interval notation, and it's the same answer. So this one was a little more complicated. If it turns into a quadratic, this is a way I like to solve quadratics, and I like to deal with this extraneous solution right here so I don't have to do more test points. If that one's not included, I don't have to think about it. So using the 5, I tested points on both sides to see in which interval it went, and I was able to figure out where my answer is. So this is how you can solve a more complex one that turns into a quadratic inequality, and you can get those kind of square root equations, inequalities rather, solved fairly easily that way. If you want more topics, or you want to go back and look at the easier ones to solve, or maybe you need to review quadratics or solving other kinds of equations, I invite you to go to mymatheducation.com or my YouTube channel, Mymatheducation. Thank you for watching. I hope you will go ahead and subscribe if you like what you've seen, and look at some of my other videos. Thanks again. Hope to see you soon.